In this section, we shall be walking you through to test that the data is sampled for normal distribution. From the Measure Minitab file, look up the worksheet Anderson-Darling test and use column C2 plastic cup weight to perform the normality test as shown. Go to Stat, Basic Statistics. Look for Normality Test. Then select Normality Test. For variables, select plastic cup weight. Check on Anderson-Darling and then click OK. You can see a probability plot of plastic cup weight on the window session. The graph shows the probability density of your data plotted against the expected density of a normal curve. Notice that in this case, most of the data point actual data are plotted on the red line of ideal normal distribution, except few data points towards the left that fall out of specs. When the data fits a normal distribution, the points, closed blue circles, will be on or very close to the Gaussian model, the red line. A p-value of 0.685, which is greater than 0.05, tells us the distribution follows that of a normal distribution for the plastic cup weight plotted in this example. There are few values on the lower side that tends to deviate away from the model. This means there are few outliers on the lower side. However, they are not enough to disrupt the normal distribution pattern as we have a large set of data points. Let's take a look at the second example of glucose level dataset. We shall be using the same Anderson-Darling test data and select the glucose level of patient dataset to perform the normality test. Go to Stat, go to Basic Statistics, then go to Normality Test. Select Normality Test. For variables, select glucose level. Check Anderson-Darling, which in this case has already been checked, and then click OK. You can see a probability plot of glucose level on session window. You can see the blue circle doesn't fall on the red line, which represents the ideal normal distribution. We can also see the outliers towards the higher and lower side, along with the outliers in the middle. Pictorially, our data is not normally distributed. Now, to further validate, we will look at the p-value, which is less than 0.005, and hence it is less than 0.05, which proves that our glucose level dataset is not normally distributed. Another way of doing Anderson-Darling test is we go to Stat, then we go to Basic Statistics, then we click on Graphical Summary and select Plastic Cup Weight and click OK. We can see a histogram on the left top side and with Anderson-Darling normality test result on the right hand side, and we can also see the p-value is 0.685, which in this case proves that our data is normally distributed. Hence, we saw two ways of conducting normality test in this session.